Why, hello, my fellow mathies. So today begins a shift. You will recall that we're in the middle of a very large quadratics unit. So the first half of the unit, we've really focused on what one would call quadratic functions, okay? In the second half of the unit, we're going to focus on quadratic equations. Now, that begs the question, which I might as well talk about right now, what's the difference between a function and an equation? If I gave you this, y equals 3x squared minus 7x minus 4, okay? That is a function. I can plug anything I want in for x, and I'm going to get a corresponding value for y. So whatever I plug in for x, I'll get the matching value for y. I could build a series of data points. I could graph it using those data points. Any input I want will render the specific output for that input, okay? That's a function. In an equation would look like this. What's the difference? Well, now I can't put anything in for x because I don't have the opportunity to get anything out for y. The y value has now been stated as 0, which means now the only thing I can do with this guy is actually solve for the x value or values that would make this statement true, okay? I can't just put anything I want in for x anymore. Now I'm looking to actually solve for x, okay? Now, it's often that you will get a parabola and it will equal 0. So when you're solving parabolas, I want you to actually have a visual of what we're talking about. I'm just going to draw a random parabola. And I want you to think about this for a second. If I was solving this parabola for when y equals 0, where am I? Well, I'm on the x-axis, okay? So when we say we're looking for the solution to a parabola, or the solution to a quadratic, I should say, the solution is the x-axis, the x-intercept, okay? You'll hear us say, what are the solutions? You'll hear us say, what are the x-intercepts? And you'll hear us say, what are the roots of the quadratic function, okay? And they're all sort of the same thing. As we go, I will kind of teach you some slight nuances between those words. But really, what I want you to gather is we're looking for an answer to an equation. What values for x would make this 0? And visually, where does this graph intersect with the x-axis? Or say this was a 7, we could be looking for where does this graph intersect with the line y equals 7, okay? Point being, in an equation, I can't just put anything in for x, I'm now solving for x. In a function, I can put anything I want in for x and get the corresponding output, okay? All right, so let's get at it here. We have been analyzing quadratic functions and the key components of those graphs. Today, we will shift to quadratic equations. The difference between a function and an equation, that's kind of what I've already talked about. It's essentially y equals something versus 0 equals something, okay? So now we are able to solve the equation by finding the solutions or roots, which are the x-intercepts of the corresponding equation. And this is what we're going to do for the next 4 lessons. Today, we're going to deal with solving by graphing. Tomorrow, we'll deal with factoring. Then we'll deal with solving by completing the square, and then we'll deal with something called the quadratic formula, okay? All right, so what I'm going to do is we're going to use this slurpee scenario, and we're going to look at a bunch of different sorts of questions that we could ask you and how we would answer them using graphing technology, okay? A slurpee thrown in the air follows the path h of t equals negative 4.9 t squared plus 12t plus 10, where h is the height in meters above the ground and t is the time in seconds. Okay, first thing I want you to do is go ahead and get a picture on your graphing calculator. And I'm going to do it with you. I think I'm going to do it with you. This would involve me being okay with switching technology in the middle of videos. Let's see if I can do this. Okay, so I'm going to do this on my Casio. If you have a TI, I'll help you out with that as well, so don't worry about that. So in order to graph the equation, I'm going to go into my graphing feature of my Casio, which is option 5 for me. you have a white Casio, it'd be option 3. And if you have a TI, it'll be the y equals button, which is right around here. Okay, so I'm going to type in that equation, which is negative 4.9 t squared, and my t would just be my variable button, so it'll come on my calculator as x squared, okay, plus 12t plus 10. Okay, and then I hit execute to register the equation, and then I draw it. Okay, now I don't have the best looking window settings right now, so I'm going to adjust that. On a Casio, oh, by the way, on a TI, sorry, you would press the graph button. It's actually the same as the Casio button. It's this button over here. It's just that yours says graph. Okay, okay, so I don't have the best looking window right now. I need to get this a little higher. I'm actually okay with my X's right now. I just need to bring my Y max up. So I'm gonna go into my window settings, which is F3. Okay, and you'll see my numbers right now. So I'm gonna take my Y max and maybe change it to 15. Just see what that does. Okay, I'm gonna change my scale to 2. TI kids following along, you have a window button and you can do the exact same thing. Okay. And now I'm just going to exit and draw again and see if that gives me a better, okay, so I'm close, but I'm still not quite there. So let's go back and we'll go maybe 25. So I'm just going to change my scale to 5 now. See if that worked better. Okay, so that'll be fine. I could take some stuff out of the X axis here that's not needed. There's a lot of dead space here. So I'm going to now bring my X min to -2 and my X max to 5, just so that I have a nice, I'm using as much of my graph window as possible. Okay, so there we go. There's a nice, decent looking graph. So this, this picture represents the Slurpee thrown and the path that the Slurpee takes. Okay, now the question I had just asked you was, what is the time spent in the air for the Slurpee? Okay, what I want you to notice is the time in the air goes from essentially here to here. Okay, so it starts at time 0, but I need to know what this number is here. Okay, so to do that, on a Casio, I'm going to go gsolve root. So gsolve root, and it will tell me 0. I can't quite read that. That's -0.66, I think. Now, that by default is the one on the left. I actually don't care about that one, right? Because it's a negative time. Although it is a solution for this particular graph, it's not a solution in this particular context, okay? So on a Casio, I'm just gonna right-click over to get to the next one, and I get this 3.106. Okay, now on a TI, you can do the same thing, but I think the easiest way to do it on a TI is to go back to your equation, press y equals, and stick a 0 in for y2. Okay, when you stick a 0 in for y2, what will happen is you'll get a line directly on the x-axis, and then you can solve for the intersection point. Okay, now on a TI, to solve for the intersection point, you go second trace 5, and then you want to right click until your cursor is right around here. It doesn't have to be right on it, but you just have to show it close to where you want it to be. And then you hit enter, enter, enter. Okay. Okay, so I'm just going to switch back to my PowerPoint for a sec. Give me one sec. Be patient with me as I switch technology. Okay, there we go. So you had a graph that looked like this. And really what we're looking for is this piece right here, okay? So from 0 to whatever that number is, and we solved for the root, and we found out when rounded to the nearest hundredth, I originally had said 3.106, but when rounded to the nearest hundredth, that would be 3.12 seconds. It's important that you follow rounding instructions. It's also important that you have your units there, okay? Because you have to answer within the context that you were talking about. Okay, what is the maximum height of the Slurpee? Round your answer to the nearest hundredth. Again, I will just take you back to the Casio and teach you how to do this on your graphing calculator, because I know some of you are still not quite comfortable with a graphing calculator. So I'm just going to switch to my calculator again. Okay, so if you are a Casio, again, everything you want to solve is in gsolve, and for you, you're just going to press your max, F2, okay? Now, It's blinking on mine because I have two equations there. So that is the equation I want. So I'm just going to hit enter. It won't blink on yours because you didn't put that y 2 equals 0 in. I was just doing that for the TI kids. Okay, so I see my x value is 1.22 and my y value is 17.35. I would write both of those down right now because I'm going to need both of them as I continue to ask questions. But right now it said, what's the maximum height? So I'm actually looking for the y value. Okay, so my answer is going to be 17.35. Before I go back to the PowerPoint though, I want to talk to the TI kids. For you guys, what you'll do is you'll go second trace again, because that puts you into your calc feature for your graphing calculator. And then you want to choose the max, just like we did on a Casio. On a TI though, it's going to just ask you some questions so it knows exactly where you want it to go. So the first thing it says is left bound. So you want to left click your cursor until you're somewhere around here and hit enter. And then it asks for right bound. So you'll just move your right arrow button until you're somewhere around here and hit enter. And then it asks you to guess and you just hit enter one more time. Okay. Okay, so TI kids can do that while I switch back to my PowerPoint. And for this guy, we got 17.35 meters. Okay. Awesome. At what height is the Slurpee thrown from? Well, I'm hoping all of you out there in my listening audience would say you don't need graphing technology for that. It's right here, right? Remember, we talked on the other lesson that that constant term is your y-intercept, which is at time 0, right? So it'd be 10 meters. That was the original height the Slurpee was thrown from. Okay, so, you know, if I'm throwing this 10 meters high, I'm throwing it off the building. Maybe I'm on the roof of Centennial. Maybe I'm on the roof of my house. I don't know, something 10 meters high. I'm obviously having a bad day if I'm standing on the roof and throwing a Slurpee, but that's besides the point. How long does it take for the Slurpee to reach its maximum height? Okay, we actually already have that answer. Remember a few seconds ago, I said, hey, write down both of those. That's the X value at the maximum. And we found that already to be 1.22 seconds, okay? All right, and then we say, how long is the Slurpee above 10 meters? Round your answer to the nearest tenth. Okay, so I am gonna switch. There's kind of two conversations I wanna have here. So I'm gonna switch back to the calculator for a second. And what I want you to see is the following. Just let me take this equation off for a sec, okay? There we go. So on a Casio, what you can do is you can do a G-solve x-intercept, okay? And essentially, I want to know, essentially like right here is the point that I begin to be above 10 meters, and here's the point I end to be above 10 meters. Now, some of you may say, I don't need that first point because I already have it. It was the y-intercept, and that's true. I just want to walk you through, most of the time when we ask you a question like this, we're not asking you to start on the y-intercept. So you would need the moment in time where I first hit 10, and then the moment in time where the second time I hit 10. That was going to be really bad grammar, sorry. And then what we'll do is we'll subtract those two time values, and that'll give us the total time I was above 10. Okay, so on a Casio, you would press G-solve and then just go to more options, and you actually want an X calc this time. So then it says enter your Y value, you'll put in 10, and it will take you to the first one, which is 0. And then the second one is 2.45. So what we'll do is we'll go 2.45 minus 0, and that'll give me 2.45, okay? On a TI, Casio kids, you can do it this way too, but on a TI, you don't have that X calc feature. So what you're gonna do is you're gonna go to Y2 equals 10, just stick that in there, and then graph, and you're gonna get a line like that. You'll solve this intersection point, and you'll solve this intersection point, and you'll subtract those X values, okay? Okay, so I'm going to switch back to the PowerPoint and show you what we did there. And so that ends up being 2.447 minus 0. So we end up rounded to the nearest hundredth, 2.45 seconds, okay? What are the restrictions on this function? So, you know, we talked about the fact that this particular quadratic, a quadratic in and of itself, the domain would be real. And the range would be for this guy, because it opens down, the range would be less than whatever the maximum point is, which is 17.35. In this context though, some of that's meaningless, right? The domain actually can only start at 0 and go to where the Slurpee hits the ground. Once the Slurpee hits the ground, like there's no point in keeping the clock going. It's not like that Slurpee is going to burrow into the ground or anything like that. Just made me think of like this alien mutant Slurpee or something. I don't know, but no, we will stop right here, because after here, all the rest of the context of this graph becomes meaningless. So the domain can only really be between 0 and 3.12, and then the range can only really be between 0 and that maximum of 17.35. Okay. All right. So solve the following graphically, round your answers to the nearest tenth. Now, I have shown you a little bit on the graphing calculator, so I won't keep going back to the graphing calculator for these examples. What I'll do is I'll just show you the picture that you should get. So what you probably want to do is you want to pause me at this point. You want to try it in your graphing calculator first, and then you want to compare pictures with me. Okay, so 2x squared minus 7x plus 4. Okay, here's the picture you should have ended up with. Now, again, I have already adjusted my window settings so that I have a nice, pretty picture. If yours doesn't look exactly like mine, it might just be that we have different window settings, so we're looking at it from a different perspective, okay? If you want to compare with my window settings, you'll notice here I've gone from -2 to 2, and I've gone from -6 to 6 in the y's, okay? And then when you go and calculate for Casio, you could just calculate the roots. For a TI, you want to go y2 equals 0 and calculate the two intersection points. But you should get x equals -0.9 and x equals 0.9 when rounded to the nearest tenth, like you were asked. Okay? All right, the second one that I want you to try, x squared minus 10x plus 25 equals 0. So pause me and do it yourself. Okay, here's the picture you should have gotten. Okay, again, I've already adjusted the window settings, so don't get freaked out if you don't see it exactly my way. I've gone from -5 to 15 in the x, and I've gone from -5 to 40 in the y. Okay, and then we see one solution here at x equals 5. Okay, one more to try. Now, this one's interesting. There's a couple different ways you could do this, okay? You could bring everything into one side and do the same thing you have done, okay? That's the first thing I want you to try, okay? So I don't like negatives if I don't have to deal with them, so I'm gonna bring that -3x squared over, and I'm gonna bring the -5 over, so I'm gonna rewrite this as 3x squared plus 6x plus 5 equals 0, and then I'm gonna graph that, okay? If you don't wanna do that, I will show you the other way in a second. But here's the picture that you should get if that's what you did. Okay, and before I dive into this conversation a little more, I want you to see that there's actually no solution here. Okay, there is no way for this graph to equal 0 because this graph will never hit the x-axis. All right. Okay, now if you didn't want to do it that way, the other way you could do that is you could put this as y1, just 6x as y1, and -3x squared minus 5 as y2. So I will bring up the calculator and just show you that you could do that as well. Okay, so we have, oh, sorry, I got ink going on at the same time here. Okay, so we have 6x that I want in y1. So I'm just going to go up here and change that to 6x. And then I've got -3x squared minus 5. And if I was to graph that, just going to go back to a standard window here. By the way, standard window, I go into my window settings and I just press F3 for standard. Okay, on a Casio, you can get, or sorry, on a TI, you can get back to standard window by pressing zoom 6. Okay, so now I see what I want to see, but I want to just dive into this for a second because I just said there was no solution. I want to make sure those two things don't intersect each other. So I'm going to play with my window here for a second because playing in math is fun and is nothing to be scared of. I'm going to go down to 20 and up to 2 for a second, just so we can get a better picture of what's happening there. Okay, and then I can very clearly see now those guys will never intersect each other. because even down here, you can see now they're getting farther and farther apart, okay? So again, it still shows me that there's no solution, okay? All right, and so my answer is, in fact, no solution. Okay, now, I just gave you 3 different ways of getting solution, or not 3 different ways, sorry. I gave you 3 different possibilities for the number of solutions. So we're just gonna summarize that right here. Number of solutions. We have just seen the 3 possible cases for the solutions to a quadratic function, and here they are. Either I could have 2 solutions where I had intersected the x-axis twice, I could have 1 solution, or I could have no solutions. Now, I said at the beginning of this lesson, there was a slight difference between a solution and a root, okay? When we're talking about roots, we're actually, there's always 2 roots to this, okay? The difference is whether the roots are real or not real, and whether they are on top of each other or not on top of each other. So you'll see in brackets, and we'll explain this more as we go, but 2 solutions is also 2 distinct roots. 1 solution is 2 identical roots. There are still 2 roots there. It's just that they're directly on top of each other. Okay, an example of that. 1, 2, yeah. So that was x minus 5 all squared, right? This would have factored into bracket x minus 5 all squared, and so it actually was an x minus 5 and an x minus 5. But I'm going a little deeper than I can right now because we haven't talked to you about factors yet. So just, I want to introduce both terminology to you right now, but we'll talk more as we go. Okay, and then the no solutions, there are still 2 roots there. They just happen to be imaginary. So we say 2 non-real roots, okay? But right now, visually, what I want you to understand is I could hit the x-axis twice and have 2 solutions. I could hit it once and have 1 solution, or I could not hit it at all and have no solutions, okay? All right, so in summary, when solving a quadratic equation graphically, what we're searching for is the points of intersection of the functions. These are roots or zeros of the equation. Next class, we will learn to solve algebraically, which will be a little bit more complicated. But remember, you can always, even when you're doing something on a test where you have to do it algebraically, you can always plug it in your graphing calculator and check your work. That way you know before you hand it in, I've got everything right, okay? All right, awesome. So that's where we'll stop for today. You've got some homework there to try, and really, you know, this is a chance for you to really get comfortable with those graphing calculators as well. Make sure you're asking lots of questions as you go through, and then we'll see you back here for the next lesson on solving by factoring. Okay, take care, guys.